So we are going to work on our 4.3 notes, which goes more specifically into translations. So overall in the transformation unit, we're going to look at translations along vectors. Our goal today will be to identify and use translations in the plane, the coordinate plane specifically, and to use vectors to describe translations. So looking back at 4.1, we already defined a translation. So our definition is that it is going to slide a figure a specific distance and translation slides a figure a specific distance and direction. A vector is a quantity with direction and magnitude. The initial point will be our starting point, and the terminal point will be our ending point. So initial point, starting point, terminal point is our ending point. The component form is the vector A comma B. A is going to be your horizontal change. We introduced this back in 4.1. We're going to get into more details and actually using it today. So that's the horizontal change. Our B is going to be our vertical change. Just a reminder, in order to find the distance from this, let's say we moved along a vector like this, okay? You're going to have a horizontal change and a vertical change. So your horizontal change will be A, your vertical change will be B. C will actually be your distance. So if you need to use the distance formula or Pythagorean theorem, you can use either of those in order to find the distance that something has traveled. So you might have to do that on your assignment today. But that's going to be looking back to Unit 1. Okay, so I'm not going to reteach you distance formula today, but you can look back into Unit 1. You can even scroll back and look at those videos, because there are videos on there of Unit 1 and finding the distance. So a translation is an isometry, just like when we did reflections. It's going to stay the same shape, same size. That's what an isometry is. Okay. There is another theorem, though, and then it says that if lines K and M are parallel, then a reflection in line K, so you can see here's our original, okay, reflection in K becomes this Q prime, P prime, and then a reflection in line M becomes Q double prime, P double prime, okay. That is going to be the exact same as going from the original over here. That's actually just a translation. So if lines K and M are parallel, this only works if you have parallel lines, then if you reflect in both lines, it actually is going to create a translation. If P double prime is the image of P, then the following is true. So if you go from P to P. So let me show you a little breakdown here that we're going to use in a second. If this is distance A, if this was A to the left, then this is a distance of A to the right. And similarly, if this distance was B, so it was B distance to the left, then this is going to be a B distance to the right. Now you'll notice that the distance between K and M is A and B together, so A plus B. And then we're going to add in another A and a B to go from the original to the new. So P to P prime is perpendicular, because whenever you do a reflection, it's always going to be perpendicular to both K and M. So this line that goes through all the P's are all going to be perpendicular, because when you do a reflection, that is going to create a perpendicular line. If you reflect again, it's another perpendicular line. So that whole line is going to be perpendicular to both K and to M. We also know that the distance between P and P double prime is not only this distance, D, but it adds in an additional A and an additional B. So it's double that distance in between. So it's twice whatever D is, where D is the distance between the parallel lines. Okay. So this next example, we are going to use coordinate notation. It says to sketch the image of triangle ABC after this translation. So to graph A prime, B prime, C prime by shifting each point. Now, how is X moving? You're adding 4 to X. So we're going to be moving 4 units to the right. It's missing the word 2. 4 units to the right, and this part, if you take Y and you subtract 5, you're going to be going 5 units down. So what I want to do is I'm going to first plot A, B, and C. So I'm going to go ahead and... Okay, so now that we have that graphed, I'm going to show you 2 different ways you can go about doing this. One, since we looked at this, we know that we're going 4 to the right and 5 down. That means I could take each point and say, okay, this one right here is going to go 4 right, 1, 2, 3, 4, down 5, 1, 2, 3, 4, 5, and this point right here is where A prime is going to fall. And I could do that with each of these points. So 1, 2, 3, 4, 1, 2, 3, 4, 5. And same with C. 1, 2, 3, 4, 1, 2, 3, 4, 5. And label those and then connect them. And we can see exactly how that triangle shifted. Okay? Now, the other way you can go about doing this, it doesn't matter because it's telling us that we're going to have to figure out where A prime, B prime, and C prime is. So this is kind of, you can find these points 2 different ways. You could have graphed it and said, this point here is at right 1, up or down 0, so 1, 0. Or, -3 plus 4 is 1, 5 minus 5 is 0, so 1, 0. Either way, you're going to get 1, 0. I don't care if you're using the rule or you're using what you've already graphed, but you do have to know both ways because sometimes you're going to be required only to find the points. There's not a graph there. And other times, you're going to be asked to graph it and not necessarily have to write the points. So, remember, to all the x's, you're adding 4. So I like to do all my x's first. So -3 plus 4 is 1. 0 plus 4 is 4. 2 plus 4 is 6. And then go back and subtract y from all your 5s. Or subtract 5 from all your y's. So 5 minus 5 is 0. 3 minus 5 is -2. 10 minus 5 is 5. And then what you can do is you can double check that these points match the points that were already graphed, since we did have to do it both ways here. And it looks like we are good to go. Identifying the vector components. So, for example, up here, if I wanted to write this in vector notation, this would be a 4, comma, -5. That's how I would write it as a vector. So, this one, it is important that you pay attention to where the initial point is compared to the terminal point, because that's going to affect whether you move left or right and then up or down. So, this vector, when we name it very similarly to how we name array. It's going to look exactly how we name array. So you're going to put your vector going to the right, and the one that's on the end without an arrow is the C, and the one on the arrow end is D. So the vector looks like ray, CD, okay? And the vector component, this moves to the right, because we have to start at C, 1, 2, 3, 4, and up 3. So 4, comma, 3. Right is positive and up is positive. Left is negative, down is also negative. Okay? So keep those in mind. I want you to try B. So pause the video, try B, and then hit play. for this one, you should get P is on the initial end, Q is on the terminal end. The vector component here is left 3, so -3, comma, -4. All right. This next part is to write the coordinates of the vertices of the image produced by translating triangle ABC using the given vector. Okay, so we do not have to graph these, but what you are going to need is you're going to need A, B, and C, what the original ones are. So A is at -2, 5. So I'm just finding where these are at, 3, 0, and 1, -3. Okay, so that's your original location for A, B, and C. Now we are going to actually have to find, if we go this route, A prime, B prime, and C prime. So again, I like to do all of my x values first. I am going to have to subtract 4 to all of my x values. -2 minus 4 is -6. 3 minus 4 is -1. 1 minus 4 is -3. Then I like to go back and do all of the y's. Y's, what you're going to be doing there is adding 8. 5 plus 8 is 13. 0 plus 8 is 8. -3 plus 8 is 5. And that one's all set. Go back and try to do B on your own. So hit pause and try B on your own. So for A prime, you should get -2, -1. For B prime, you should get 3, -6. For C prime, you should get 1, -9. Okay, so if you flip the page, sorry if you weren't done making sure you have those right, you can go ahead and hit pause if you need to. But if you flip the page, you are just doing all different kinds of things with translations on this assignment. It says, 4 playing cards are face down on the floor. Name the transformation. So if you go from A to C, what type of transformation is it? So this is actually kind of like 4.1 because it is an overview. Is it going to be a translation, a rotation, a reflection? So you're going to name those. Match the graph with the description of the translation. So for 5, 6, and 7, for number 5, how does this one move? Does it match A, B, or C? Same with 6, same with 7. Consider the translation that is defined by the coordinate notation xy goes to x plus 4, y minus 4, or y minus 6. Notice, it says what is the image. So this is the pre-image. You're going to take this, you're going to perform the operation, and what do you get? However, there are 2 in here that are what was the pre-image. That means you took an x, you added 4, and got 0. So what was the x that you had that you added 4 to it to get to 0? Okay, this is the answer. You were trying to find the question, kind of how like these ones are. Okay, but you're working in reverse. So pay attention to that pre-image versus image. Draw the image of ABCD after the translation. So you're going to have 4 images drawn on this graph, 5 if you include the one that's already there. So for 14, 15, 16, and 17, you should have 4 images drawn. If you want to also find A prime, B prime, C prime, and D prime, you can do that. I am not going to be worried about that, but it might help you if you just write out how this moves. This moves right 1, up 4, so I'd probably write that and then move A. And if you want to color coordinate this and do it 4 different colors, that might help you too. Looking on the back side, naming the vector and write its component form. That's exactly like the notes. So name it, write the component form. Draw and label the vector given the name and component form. So this one, it gives you the name. It wants you to draw the arrow. It does not matter where you start your arrow. Okay. This one, it says a vector has an initial point here, a terminal point here. Write the vector in component form. Find the magnitude. That means the distance. That's where I was saying you're probably going to have to use that distance formula. Okay, so you're going to have to look back to Unit 1 to find the distance formula if you do not remember it. That's good review because you're going to need it for the exam in a couple weeks too. Draw the image of the figure under the given translation. So 25, it gives it to you in component form. Same with 26. 27 says use coordinate notation to name the translation. Okay, so how does that one move? Write it in coordinate notation. So what it wants you to do it is like the x comma y goes to, how does that change? So write in your rule. And what distance does each point move under this translation? Again, use the distance formula here. You guys have questions? Let me know.